can hear me properly, right? Yeah. So let's solve prefix sum pattern. First, let me solve it. So what does it mean? So this is your array, right? So assume that this is your array. Assume that it has 0, 1, 2, 3. So prefix sum means, for example, this is an index you are pointing. Prefix sum means what is the sum of elements you have before this index. So we call it as prefix sum. And suffix sum means what are the sum of elements you have after this element. For example, you have one more index, which we call it as suffix sum. So this is a beautiful pattern. Actually, most of the complex problems you can solve through this concept. Uh, if you don't know there is a kind of pattern exist, something like this, it would be difficult to track the problems. So while solving the basic problems, you feel more comfortable, but when you are applying these concepts into sliding window, sometimes on dynamic programming, it really matters. So let's take a couple of problems on it. So we have, let's move on to this. Let's say you will be given an array. So this is an array. We want to find out running sum of one dimensional array. So let's say what he is trying to say. So assume he given an array of 1, 2, 3, 4. So 1, 2, 3, 4. So this is an array. So we want to figure out running sum of an array. So running sum means, so at this point in time, the sum of an array is 1 at this point of time. So running sum means the current, wherever you are pointing, we need to figure out sum of all those elements. So here you are here, right? So sum of these elements, obviously here it is going to be 2 plus 1, so which is 3. Now when you come here, so we need to figure out sum of all these three elements. So you can figure out sum of all these elements, so which is going to be 6, right? So here it is 6. Then when you are here, so obviously figure out sum of all these three elements, so which is going to be 10. Do you hear any background noise or it's fine? Okay, so actually I am recording at the same time, right? Uh, yeah, it's a personal laptop and it's giving a lot of noise, but let me know if you feel it. Okay, so it's a simply we need to find out running sum. So how do you solve it? Can you give me brute force? So this is called running sum. How do you solve it? Can you tell me the brute force? Hmm. We can maintain two loops, yeah. So what is happening? So you are here, 0, 1, 2, 3, right? So generally what is happening? So you are at 0th index. Somebody is trying to join. Okay. So we want to figure out running sum, right? So let's say how can we do that? So you are at 0th index and you are traversing. You don't need two loops, but let's see what is happening here. Can you guess it? If I explain it, it is fine, but finding out the brute force solution for it is more tricky so that you can enjoy the concept of prefix sum. So if I write the prefix sum directly, then you don't feel much. So this is what you have, right? So 1, 2, 3, 4. So it has indexes as 0, 1, 2, 3. we need to figure out a running sum. So at this point in time, the sum is 1. At this point in time, the sum is 3. It means we need to figure out sum of these two elements. When you have here, we need to figure out sum of these three elements, obviously 6. When you are here, the sum of these 4 elements, obviously 10. So what is happening here? Tell me. Okay, we need two for loops. If it is a brute force, we need a two for loops. Then what are the values do we need to pass? Or do we really need two for loops? Please respond. No? Yeah. No, no, that is optimal. I want to know the brute force. Yeah, optimal is fine. The problem with data structures is our brain, right, don't think of brute force and it's keep on focusing on optimal because that's how we trained. To get into the pattern in a best way, first you solve everything in brute force, then understand what are the problems in it, then try to match the associated problem. So here we need to figure out a brute force. So what is happening when you are here, right? Let's say when you are here. So what is the when you are here? What is the sum is 3? How do you know that the sum is 3? Yes, right. Index 0 to the 1. So we added this here. So when you are here, sum is 6. How do you know that sum is 6? Correct, right? So it means each time when you are here, the sum is 10. How do you know that the sum is 10? So we are starting from index 0 and moving towards the current index. And we are trying to figure out a sum of that element, right? So simple, right? So you are starting from index 0. So you don't need two for loops for sure. Why? Because when you are here, so we are trying to do what? From index 0 to index 1, what is the sum of elements? When you are here, you are trying to figure out from index 0 to index 2, what is the sum of elements? So when you are here, you are trying to figure out from index 0 to index 3, what is the sum of elements? Right? So if I simply write the brute force logic, so this is how it looks, right? Simply you are having, you are starting from, this is your index, starting from 0 and which is moving towards length of an array, and each time it is just increasing. So what you try to do, you need to, this is, assume that this is your array of index. You just need to figure out, get sum of from 0 to current index. So this is your array. That's it, right? So you need to figure out a get sum of from the 0th index to current index. From this array, you need to figure out a sum of all the elements. Yes or no? Yes or no, please. Correct? Huh? So let me do that. So what you are trying to do? So one thing for sure, we need a utility method. So which is get sum, which will just take the start index and which will also take the end index, and it is also taking the given input array. So which is going to return sum of those elements, sum of the array from the between those indexes. So you have sum is 0, and what you do, so this is your start which is less than or equal to end, and you just write sum plus equal nums of start and start plus plus. So finally you return sum. Simple. So it is simply giving sum of the elements between these two indexes. Now what is our job? So we are starting from index 0. So we are starting from index 0 and we move till nums dot length index plus plus. So simply we are just trying to find out, we'll take some result array or answer. Okay, so simple. We'll just write answer of index, which is equal to get sum of. Each time we are starting from zeroth index, moving towards current index, and finding out the sum, so which is going to return by the get sum. And finally, we will just return answer, right? So if I run it, let me log in. Did you understand what is the repeating thing we are doing here? Then we can improvise it. So let me run it. Nums. Okay. What else? So it will definitely, if I submit, it will definitely give a time limit. Can you tell me what is the mistake we are doing here? Yeah, every time we are trying to starting from zero, right? So what is happening here? Then we will try to figure out the solution. So this is what we have, right? So we have 1, 2, 3, 4. So 1, 2, 3, 4, which has 0, 1, 2, 3. So what we did is, first we figure out a sum 0 to 0, so which was written 1. Then we figure out a sum 0 to 1, which was written 3. Then we figure out a sum of 0 to 2, which was written 6. Then 0, 3, 3, which was written 10. So that is what we did, right? So this is what happened. If you closely see, if you closely see, when you are figuring out a sum of 0 to 1, so you are trying to find out what you are trying to do here. Can you tell me? I want to hear from your end. 0 to 1, right? So when you are calculating 0 to 1, so what you are trying to do here, right? So we are adding index 0 to the index 1, so that is clear. So what is the repeating thing we are doing here? 0 to 1, right? So 0 to 1, so which includes the sum of 0, 0 and sum of 1, 1, right? Right? So 0, 0 index 1 and sum of 1, 1, 1 here. So we already calculated 0, 0 value in the top, right? Similarly, when you are doing 0 to 2, so what it's trying to do, it is trying to include sum of 0, 1 plus sum of 2, 2, right? So index 2, 2. Similarly, when you are calculating 0, 3, so which is including sum of 0 to index plus current index, which is 3, 3. So if you closely see, whatever you see here, right? Whatever you see at last, whatever you see at last, which is always pointing to current index, yes or no? This is 1, 1, this is 2, 2, this is 3, 3. So assume that when you are trying to solve for, if I write here, if I closely see, so which is sum of 0, 0 plus 1, 1. If I close here, which is sum of 0, 1 plus 2, 2. It means you need to calculate 0 to 1 sum plus current index sum, which is 2. And because this last value is always representing the current index. And similarly, which is calculating 0 to 2 plus current index 3 comma 3. So what did you understand? So what we are trying to do is whatever result we are doing repeated logic, right? So when you are doing 0 to 1, so we are just blindly within our logic, we are blindly starting from 0 and we are trying to move on to the current index, but we are not understanding that we already calculated previous result. So when you are trying to solve 0 to 3, prior to that you already solved 0 to 2. When you are trying to solve 0 to 2, prior to that you already solved 0 to 1. So when you are solving 0 to 1, prior to that you already solved 0 to 0. So the point is, when we just need to, we already have previous sum result. To the previous sum result, we just need to add current index value. That's it. This is what the concept of prefix sum. So so that let's understand what is the time and space complexity for this brute force approach. What is the time and space complexity for this brute force approach? Repeat now. You better speak, everybody. Um, Order of this logic time complexity. It is n square, right? Why? Because what is happening for every index you are starting from previous index, right? So when you are 3, you are starting from 0 to 3. When you are 2, you are starting from 0 to 2. That's how it is happening, right? Of course, we are not writing two for loops, but this get some method is internally the inner for loop. So which is keep on starting from 0 to, hope you get the clarity on it. So this is n square. But what is the space complexity here? It's not constant because we are taking answer array and we are storing the result, right? So this is a space complexity is order of n, and time complexity is n square because simple, right? 0 1 0 2 0 3 0 4. It means every time we are trying to, for the last index it has to start from traverse all the n elements. For n minus 1 index it is trying to traverse n minus 1 elements. So that's how it is n into n minus 1, which is n square. So now you understand what is the repeated thing we are doing. So let's try to figure that out. Okay. So we understand that we have 0 0 1 2 3 4, right? 1 2 3 4. So 0 0 the sum is 1. So you are here. Now we want to figure out 0 1. So when you want to figure out 0 1, so we know that sum of 0 0 plus 1 1. We already know that we already calculated the 0 0 sum, so which is 1 plus 1 1 means 1 in 1 1 index you have 2, so which is equal to 3. Now when you want to figure out 0 2, so we need to say 0 1 plus 2 2, and we already figure out what is the value of 0 1. This is 1, so 0 1, so which is going to be 3 plus current index 2, you have 3, so which is equal to 6. Now similarly 0 3, then we already know that it is sum of 0 2 index plus the current index, which is 3 3. So 0 2 index sum we already calculated 6, and the current index is 4, so plus 4, so which is going to be 10. So we figure that out 1 3 6 10, right? Now we just what did you understand is every time where this is current sum, right? So when you are here, the current sum is 1. When you are here, the current sum is 3. When you are here, the current sum is going to be the 6 for the next element. So what we are trying to do, so we are holding, when you are trying to solve 0 2 3, we already calculated 0 2, we call it as prefix sum. Prefix sum. So what is the sum of elements prior to this index? So we call it as prefix sum. So we already calculated prefix sum. To that prefix sum, just add the current element. That's it. So you will get the result. Now, can you tell me what is the time complexity here? I think you get how to write the logic, right? So what we are trying to do every time we are trying to figure out a prefix, we will consider a prefix sum variable, and first time it is 0. So when you are here, the prefix sum value will become 1. Then when you are here, the value is going to be prefix sum plus current element. So we'll update the prefix sum to 3. So when you are here, the value is going to be prefix sum plus current element. So prefix sum is 3, current element also 3, so which is going to be 6. So we'll update prefix sum to 6. Now when you are here, 0 2 means prefix sum plus current element 4, so which is going to be 10. Now, do you understand the logic, how to write the logic? Understood? This is how it is, right? If I simply, can you tell me what is the time complexity? Yeah, so obviously it is linear. And what is the space complexity? So where are we storing the result? This result, right? This is the result array. So we need to return this result array. Where are we storing this result? Prefix sum will have only the latest value, right? But you need to return an array which has the sum of all the elements. Yes or no? Right. So what I'm saying is this is not traditional class, no? So better you come up with all dummy questions. We will try to spend some time. There is no time bound for this training, so that at least our things will get clarified. Okay. So one way is now you know how to write the logic, right? So simply you take prefix sum which has 0, and you will start from I0 to n, I0 to n. So what you do, so you will just write prefix sum plus equal to nums of I, right? So you will get that. Where do you store this value? So this is the current index prefix sum, right? Or you can say running sum, whatever it is. So this is the current index. Now prefix sum is equal to, now you get the current index total running sum, right? So where do you store this value? So at the end of the day, we need to return this array now. We need to return this array, right? So this is the array we should return. The prefix sum will always hold the current sum. So where do you store this value? Do we need to take additional array, or do we not need not to take additional array? Mm, yes. Why? Because yeah, let me first write the without take by taking an array, then we will address it. So this is your input, right? So what we do, we will take prefix sum. So initially which is 0, and what is our logic? Prefix sum plus equal to nums of index. So we'll take the previous prefix sum, or I'll just do this. Prefix sum plus nums of index. And finally, this is your answer of I, answer of current index, which is going to be prefix sum. But if you, for clarity's sake, I make it as prefix sum, better you consider it as running sum, whatever it is. Simple, so we'll just run it and submit. This will work, but this needs an improvisation. So how do you do that? So the problem is we are additionally taking we are taking additional array, right? I don't think we need to consider this additional array. Why? We can skip the considering additional array? Yes, we can update in the same. Do you see any disturbance by updating the same index? Ajay, Kalyan, Banu. Obviously not, right? Why? Because if you say I'll just remove this, I'll take this nums of index equal prefix sum. What you are trying to do, so prefix sum you are calculating, you take the current index value, right? So first you take the current index value, update the prefix sum, then update the value into the array. Okay, so there won't be any disturbance, right? Correct? So then here the space complexity becomes, what is the space complexity? It becomes constant. And do you really need this? Do you really need prefix sum variable? Correct? So what we can do, this prefix sum, right? This prefix sum is representing, what is the value this prefix sum is representing? Closely observe, we are updating everything into the nums of index, right? It means when you are at nums of index, when you are at the nums of index, the prefix sum is already present in nums of index minus 1, right? Yes or no, buddy, please? This is more important to understand. So the prefix sum present in nums of index minus 1. So do we really need it? We don't need it, right? So we can skip it. So you can directly start from 1 because for 0, for 0th index, the prefix sum will remain the same. So nums of index equal nums of index minus 1 plus nums of index. That's it. See how we evaluated the same problem, right? So that's how you think. It's not a straight thing, you get it in a single shot. Give a multiple tries. That's it. So now we just calculated it as a single line code. Understood? Understood this concept? Yeah. So I think there are a couple of solutions we write, but don't get into the optimistic solutions straight away. The problem is when you really write the competitive code, right, you always get the unknown solution. So when you get the unknown solution, as if you're seeing this problem first time in your life, right, you feel the same. I think you might have done some coding. You feel this becomes very easy. You get into the optimistic solution straight away, but that is very bad habit. Better you try to come up with multiple solutions so that you can build that pattern. Now you understand the concept of prefix sum, right? So prefix sum is you always maintain the previous elements sum into in temp variable, or you can use in place algorithm. We call this as a in place algorithm. So let's move on to the next question. So this is yeah, let me take this. Yeah. Range sum correlate. Simple. So what it does is yeah. So he's saying is the array is immutable. Okay. The array is immutable. What do you mean by immutable? What do you mean by immutable? The state of an object cannot be changed. For example, you have an array. Assume that the array is having elements. In this case, is having elements minus 2. Let me take some other input. Okay. Or we can take anything. So let's say you have an array as minus 2, 0, 3, minus 5, 2, and 1. So you have element 0, 1, 2, 3, 4, 5. So these are the indexes. So what he's trying to do, what he's trying to say is this array is immutable. Immutable means once you assign a data to that an array which cannot be modified. That's it. This array is immutable. This is more conceptual thing. If the array is mutable, right, our solution will not work. But the array is immutable, so it means once you, I'll explain about why it will not work. We should go with the segment trees, but that we will learn later. Now here array is immutable to make it simple, and you have an element. Simply what he's trying to do is, what he's trying to understand is, you want to find out some range of, there are two methods in it. There are two methods in it. So you have array, and you need to find out a sum range. So you will give the left index and right index. We need to find out the sum between those two indexes. So if you closely see here, assume e given sum range of 0 to 2. So in that case, we need to figure out the sum between index 0 to index 2. So it means till here to here. So obviously the sum is 3 minus 2, right? So which is 1. So here the output is 1. Similarly, he given one more range 2 to 5. So we need to find out the sum range between 2 to 5. So till here to here. So obviously the sum again is 1, right? So minus 5 plus 5 plus 1, so which is 1. Okay, so you get 1 here. And let's move on. He also said to find out some range from 0 to 5. 0 to 5. So we just need to find out some range between this to this. So obviously, which is 4, right? I think it is 4. Minus 1, I think. Yeah, it is minus 1. If you closely see, it is minus 1. So this is what the expected output. So minus 1 or minus 3. Do we take input wrong? Minus 2 plus 2, which is 0. And minus 5, 1, 4. I think we take an input wrong. Yeah, yeah. This is minus 1. Okay. So then minus 2, 0, 3, minus 5, 2, minus 1. Okay. So it is minus 3. Okay. Tell me how to write the logic. Tell me brute force logic. What is brute force logic? What is brute force logic? You know it right already. Brute force. Yes, that's it, right? So which is going to be the brute force? Now you want to come up with optimistic solution. How do you do that? Which is little tricky, right? So you're always giving this needs a little math. This needs a little math. Let's suppose you maintain a prefix sum of all this array. So let's say we know already prefix sum, right? Okay, you get a blind thought. I'll go with prefix sum. So here minus 2 you get. Here also minus 2. Here you will get plus 1. I'm just randomly calculating. Prefix sum you already know, right? So here you will get plus 1. So when you are here, plus 1 minus 5, so which is going to be minus 4. When you are here, minus 4 plus 2, which is going to be minus 2. And when you are here, so minus 2 plus minus 1, so which is going to be minus 3. So you already have indexes 0, 1, 2, 3, 4, 5. So obviously 0 to 5 means obviously you get the last one, so which is minus 3. Now you want to find out 2 to 5 from this prefix sum. How do you figure out? How do you figure out? You need to find out, closely understand. You tell me the logic. So we need to find out the sum of these two elements, correct? Yes or no, please? From here to here, right? From here to here, you will calculate the range sum. So what is the time complexity then? Yeah, it should be n squared. So can you come up with a better solution? Tell me, please. It is minus 1, right? I think here it is minus 1. We updated the last value. Think now. One solution is why you need to do that, right? So if that is the case, you don't need to maintain this sum also. Now you can directly depend on this. What's the point of having this? If you calculate from here, definitely it will give wrong result. You should, if that is the case, you should calculate from the source array. If you want to find out sum of 2 to 5, right? We already calculated prefix sum, right? We already calculated prefix sum. Yeah, we already have it, right? So we already calculated prefix sum. We want to find out sum of these elements. How do you know that the sum of these elements in a constant time? Okay, so let's say what it is trying to say. What it is trying to say, it is going to give total sum till index 5, right? So total sum till index 5 means this one. So minus 3, right? But what minus 3 is representing, please? What minus 3 is representing? So you given 5 means I need to go to the last one, so which is minus 3. What is this representing? Sum from 0 to 5, right? So okay, sum I need to find, but we need to find out sum from 0 to 2, right? Sorry, 2 to 5, right? 2 has to be included, right? So we need to find out, sum between 2 to 5, right? But we have a sum of 0 to 5 minus 3, right? So we, if you want to find out 2 to 5, we already have a sum of 0 to 5, but we need to subtract the previous value, right? So you have 2 to 5, so we have a 0 to 5 value. How do you know that it is 0 to 5? You don't have any option, you directly move on to the last index, so which are always representing from 0 to 5. From here you need to subtract previous elements, right? So this is what we need to do. So we already have 0 to 5, but we need to find out sum from 2 to 5. It means we need to subtract this part. Yes or no? This part. It means till here we need to subtract. So how do you know that? You already calculate the prefix sum of each index, right? So we need to find out a sum from 2 to 5, but we calculated 0 to 5. So from this part is to be excluded. So you already know prefix sum of index minus 1, right? So 2 to 5 means 2 before whatever index you have. We just need to subtract 0 to 1, right? So why 1? Because we are starting from 2, so that 2 before what is the prefix sum we have, we just need to do that. So it means obviously if you see here, what is the result you have? 0 to 5 is minus 3, minus 0 to 1 value is minus 2, so which is minus 1. That is what the expected output, right? Similarly, if you want to know 0 to 2, so 0 to 2 is direct answer. So 0 to 2 means obviously till 2 you have value as 1, so just take that 1 minus, you can't subtract because first index is 0 now. As the first index is 0, you don't have any index prior to that, so that you don't need to subtract. So that edge case we need to handle in the code. Do you understand what I'm trying to say? Everyone, please. I know I didn't go in detail to this, but hope you get it. Or do you need explanation? Okay, so let me do that. Next problem, you do exercise. I will close the session with this problem. So you have minus 2, 0, 3, minus 5, 2, minus 1, right? Okay, so this is your index. So what is trying to say is we want to find out sum of 2 to 5. So if you want to find out sum of 2 to 5, so this is 2 and this is 5. So we need to figure out sum of these 5, these elements. So obviously it is going to be 1 minus 1. How much? Minus 6 plus 5. So obviously, again I took wrong input. Yeah, it is minus 1, minus 1, 2, 3. Okay, so how much is the result? Minus 1. But here, okay, 2 to 5, right? Okay. So which is minus 1. So obviously the sum of these two elements, this is 0, 1, 2, 3, 4, 5. So the sum of indexes between 2 to 5, which is minus 1. So one brute force solution is from starting index to ending index, you traverse to the array, find out a sum. But if you come up with optimistic solution, what we blindly know is we know the prefix sum, right? So this is our prefix sum array. So you have 0, 1, 2, 3, 4, 5. So you are here, the prefix sum is minus 2. So when you are here, the previous value plus current value, which is also minus 2. When you are here, current value is 3, so 3 minus 2, so which is going to be plus 1. When you are here, current value is minus 5, previous value is 1, so which is going to be minus 4. When you are here, current value is 2, previous value is minus 4, so which is going to be minus 2. So when you are here, current value is minus 1 and previous sum is minus 2, so which is going to be minus 3. Now the ask is we need to find out sum of the array. Yeah, so we need to find out sum between 2 to 5, right? So we need to find out sum of indexes between 2 to 5. So the point is, we already, for example, so, we don't have any option, right? So we don't have any option. So we are maintaining prefix sum based on the last index. So the last index is 5. So here we have minus 5, minus 3, right? At last index you have minus 3. But this minus 3 is representing sum of 0 to 5, right? So it is a sum of 0 to 5. So this minus 3 is representing the prefix sum from index 0 to index 5. So this is what we should carefully understand. So which is representing sum of 0 to 5. But the ask is we need to find out sum between 2 to 5. So we know at each index, what is the sum, right? So I can write this sum of 2 to 5 can be written as sum of 0 to 5 minus, so 0 to 5, but we need to know the sum between 2 to 5, right? It means the 0 to 5 includes what? The 0 to 5 includes what? If I simply write sum of 0 to 5, so how do you know that? So it is sum of 0 to 1 plus sum of 2 to 5, correct? This includes sum of 0 to 1. Understood, right? So it is a 0 to 5. I can write it as 0 to 1 and 2 to 5, correct? Which includes all the indexes, no? Yes or no? Sum of 0, 5 includes sum of 0, 1 and 2 to 5, right? So which includes all the indexes. Now if I want to know sum of 2 to 5, I can say that sum of 0 to 5 minus sum of 0 to 1, right? Simple math, no? So 0 to 5 means you already know, which is minus 3, and minus sum of 0 to 1 means at first index. 1 means 1 only, no? So at first index, what is the value? You have minus 2. So it is minus 3 plus 2, which is going to be minus 1. So if you want to find out the sum of 2 to 5, so you can simply write as sum of 0 to 5 minus whatever start index you have. Prior to that index, you need to consider. So because if you see this diagram, we want to find out sum of this one. So, but this minus 3 is representing total sum. So what you should do, if you want to consider this, you need to exclude this. So that's what we did. So we just take 0 to 5 minus sum of 0 to 1. Hope you get it right, everyone. So what is the time complexity? Order of n, right? Order of n, because we are constructing the prefix sum, so which is order of n. What is the space complexity? Yeah, if you take additional one, which is linear, it's up to us how do we want to take the space. Uh, so, if you closely see, this guy is taking nums into that local variable. So obviously we need to consider additional array. So you can take prefix array. So I can simply say prefix you can take array, simple, new integer of nums dot length. There is no option we have because this guy is giving it as a local variable. Okay, so now you know how to calculate prefix sum, right? So index 1 to index last. So obviously array of 0 will have nums of 0. So now array of current index, which is going to be array of current index plus array of index minus 1. So we done. So we are done with constructing the complete prefix sum array. And yeah, so you can say if left is pointing to 0, then you can blindly return array of right. It means you already know you already know that, right? So if you closely see, each one is representing, if you pick up this, which is a sum, prefix sum from 0 to 3. If you pick up this, it is a prefix sum from 0 to 4. Similarly, this one. So everything is current right is pointing to prefix sum from 0 to 1. So if left is 0, you can directly return right. Otherwise, what you can do, you can return array of right. It means the total sum minus array of left minus 1. Correct? So left is pointing to starting index, right is pointing to ending index. You already know what is the previous value, previous prefix sum, which is present in left minus 1. You just return that. That's it. What is the issue? Are we doing any mistake? Minus 2, 0, minus 1. Okay. This is our right. You have left minus 1. This is fine. Constructing prefix sum also fine. This is 0 starting 1 till n. Find out a issue here and we will try to figure out a solution. Where is the mistake? Let me print this array. Are we calculating properly? So this is minus 2, minus 2. Yeah, so the array is not, the prefix sum is not calculated properly. So let's see what is the issue here. What is the issue? Tell me, man. Prefix sum, one thing for sure, prefix sum is not calculated properly. What is the issue? Tell me, please, at line number 7. There is an issue at line number 7. Can you understand that? No, that is also wrong. Array of index minus 1 contains what? Where to give? Where to give? Okay, there are two things, right? Array of index and array of index minus 1. So, where should I apply nums? In both places? Yeah, so that's the issue, right? So the current element is present in nums of index. Current element is present in nums of index. Prefix sum is present in array of index. Index minus 1. So that's why the current array of index equal array of index minus plus nums of index. It's a problem we did with the previous thing, right? In the previous one, we blindly considered on the same one. So that's where it went wrong. So, yeah. So what is the time complexity of this sum range? What is the time complexity of this sum range? Tell me, man. Sum range time complexity. Yeah, it's always constant, right? So for building the prefix sum, we are taking additional space, linear space, and linear time complexity. But for this, the time complexity is constant. It's just taking the values from the caching values, right? So these are two interesting problems. Spend very good time, understand what is happening in the background, and try to solve it. Uh, if you try doing this find pivot index, I'll also add GitHub link here so that you can also see the notes over there. I think notes I mean this rough notes, whatever notes we prepared, right? This rough notes you do it. Whenever I type an algorithm, I can share with you. Otherwise, you can get this rough notes. Try solving this the problem number 724. Don't look at the solution, but it is more or like this second problem. But you need to put a little brain, slight change. Try solving this, and I'll try to take few more problems tomorrow. Then we will go step by step. Okay. Thank you. Any questions? No questions? Yeah.